So welcome on this webinar. So this live event for the MOOC Virus and Human Cancer. I am Clémentine Schild and I'm the head of digital education at Institut Pasteur. And we are waiting for all the participants to enter the room. And then we leave the floor to Rodolphe SUSPENE.
Okay, so hello everyone and welcome to our live session of the MOOC Viruses and Human Cancer. So I'm Rodolphe SUSPENE, your community manager, and today we are pleased to have with us Pascal PINEAU, who is Director of Research in the ONO units, ONO for Nuclear Organization and Oncogenesis. Pascal PINEAU has been working for many years on HPV and the development of liver cancers. We have also with us Mr. Jean-Pierre VARTANIAN, Director of the Virology Department and Director of the Viruses and Cellular Stress Unit. Jean-Pierre VARTANIAN is also the creator and director of this MOOC. Jean-Pierre has been working for years on the link between viruses, inflammation, and the development of cancers, with ApoBex3 cytidine deaminase as common points. First things, I would like to thank you for all your questions. This year we have received many questions. We will try to answer them, but if we don't have time, I will answer you via the discussion forum. And big thanks to you, to Pascal and Jean-Pierre, for being with us today for this live session. So I think that we can start with the first questions concerning papillomaviruses. And one student asked us, if HPV mainly infects the skin and mucous membranes, how are they today involved in brain tumors if there is no viremia? So I think that Jean-Pierre can answer at these questions, but I think that it could be first necessary to clarify the term head and neck, please.
Yes, thank you. Thank you, Rodolphe, for asking this question. Yes, there is a different point in that question. The first point is the papillomavirus involved in brain tumors, the first question, and then why if there is no viremia? Just to remind you, papillomaviruses are double-stranded DNA viruses. The size of the virus is more or less 8 kilobases, and these viruses belongs to the family of Papillomaviridae. And the tropism, you have two different types of tropism. You have cutaneous tropism and mucosal tropism. Okay? So when we say brain tumors, it's not really brain tumors, it's head and neck cancer. And what is head and neck cancer? It's just, in this case, associated with infection of papillomaviruses. Of course, you can have brain cancer or head and neck cancer, which are not associated to papillomaviruses. So it's two different things. So now we are talking about head and neck cancer associated to papillomaviruses. And these viruses are linked to cancer, head and neck. It's mainly lips, tongue, mouth, throat, larynx, and salivary gland or the sinus also, but not in the brain. So this is head and neck cancer. And those cancer are linked with high oncogenic papillomaviruses that infect and give oropharyngeal cancer. At the opposite, you have some other papillomaviruses that infect mucosal, like HPV 16 or 18, and they are linked with cervix cancer, vulvar cancer, penile cancer, anal cancer. So this is the two different types of cancer. Now, the question is good because there is possible to get head and neck cancer when you are sexual relationship with someone. So in fact, you have different type of infections, and the head and neck cancer which are associated with papillomaviruses is oral sex practice mainly. And those type of cancer are also done involved with papillomaviruses. So that I think in the next questions, we will differentiate the different, when we'll talk about vaccine, we'll differentiate the different type of papillomaviruses. There is 200 genotypes, which some are oncogenic and some are not oncogenic. And then we can discuss later. So I think that I have more or less answered to that questions. If it's not clear, you can write on the chat.
Okay, so thank you, Jean-Pierre, for your answer. And I see that we have two other questions regarding papillomaviruses. One student would like to know, I would like to know why we have so much trouble developing a single HPV vaccine that's effective against virtually all the most carcinogenic serotype.
Thank you, Rodolphe. Here again, there is two questions in one question. The first question is it possible to make a vaccine against all types of papillomaviruses? The answer is, I would say, yes. And the other questions I see in that question is it possible to protect all types of cancer with the vaccine against papillomaviruses? And this is, of course, no. If you make a vaccine against papillomaviruses, you will be protected against infection by papillomavirus, but you will be not protected against infection by hepatitis B virus, where sometimes you have a link with hepatocellular carcinoma. So we need to understand that such vaccines will protect against infection by papillomaviruses. This is the first thing. The second point is it possible to protect infection? Yes, of course, because now in France we have a vaccine which is named Gardasil, where you have 9 different genotypes. The most oncogenic papillomaviruses are present in this vaccine. The vaccine is an inactivated vaccines, which is done with one of the protein of papillomaviruses, which is a late protein L1, which is forming pseudo-viruses, just only done by L1 capsid. And this will, of course, protect against cervix cancer. We have to know that 99% of cervix cancer, it's due to the papillomavirus 16 or 18. Okay, in general, you have no cervix cancer which are not associated with papillomavirus. So the vaccines will protect against cervix cancer associated to papillomavirus, but also to oropharyngeal head and neck cancer associated with papillomavirus.
Okay, we have a last question about papillomaviruses. Why do HPV lesions not always lead to cervical cancer?
I would say that you have different type of papillomavirus, of course. We know that we have, as I said, 200 genotypes. In fact, I don't really understand the question.
I mean, I can maybe give a comment.
Yes.
Yeah, sure.
It is a general phenomenon with virus-associated cancer that all infected people do not develop a cancer, and it is fortunate because most of us are infected by at least one of these viruses: papillomavirus, Epstein-Barr virus, sometimes occult infection with HPV. So, I mean, the oncoviruses are quite widespread, and even though you are infected by one of these viruses, you have to accumulate additional risk factors to allow the progression of the disease. And it is the same for papillomavirus. Often the infection are associated with other risk factors, tobacco, smoking, or specific condition related to the local environment of the patient to enable, unfortunately, the development of the tumor. But it is a general fact that all people in the world infected with an oncovirus will not develop a tumor.
Yes, in fact, yes. It's not because you catch such virus belonging to HPV 16 or 18 that this will be correlated with, for example, cervical cancer. You can be infected and never develop a cancer.
Okay, thanks for your answers. And we have two similar questions for you, Pascal, concerning the role of epigenetics and particularly methylation in the development of cancer. So when people ask us, what is the influence of methylation in the development of tumors when we know that it represents a major parameters for viruses such as EBV, so Epstein-Barr viruses? Indeed, methylation regulates virus dormancy, but can also silence tumor gene suppressors. And the second one is more a remark. It would be interesting to look at the indirect epigenetic influence of viruses, such as methylation, on the onset of cancer. I think you can tell us some words about this, please.
Yes, I will do my best.
Thanks.
Concerning EBV, of course, the DNA methylation of EBV genome is a part of the life cycle of the virus. So it enables the virus to be stealth in the organism, in the body of the infected person, and for a reason or another, according to event that modulate immunity or to the exposure to chemicals or other compound that may change the homeostasis of the infected cells, it will again it will wake up and be part of tumor development. But this mechanism that is controlled by epigenetics affects as well the genome of the patient. Epigenetics, it is the DNA methylation, or it is the histone modification through methylation or acetylation, and it is this chemical modification of protein or nucleic acid, of chromatin in general, are really important for the development of the tumors. And there is huge variation of DNA methylation according to the organ you are considering, and there is huge variation according to the agent responsible for the development of the cancer. I'm myself working on tumor from South America, from Peru, where DNA methylation is much more important than DNA mutation. There is methylation and few mutation, while in sub-Saharan Africa or in Eastern Asia, liver cancer is, on the contrary, more often linked to the presence of abundant DNA mutation affecting tumor suppressor genes. So the student asking this question is true. There is the epigenetic is really important to trigger at least a subset of tumor of any kind, in fact.
Okay, thank you, Pascal, for your answer. We have one question concerning viral integration into germlines. What about viral integration in germlines? This aspect is not very much addressed in this MOOC. So, Jean-Pierre?
Yes, thank you, Rodolphe. In fact, it's very important that germlines, if germlines is infected, means that you can transmit the virus to the next generation. So this part is very important. Is it possible to have the germline infected? Yes, of course, it's possible. It's mainly done by retroviruses. And if you make the deep sequencing, the total sequencing of the genome, you can find that more or less 10% of the genomes belongs to some integrated virus. Integrated virus, in this case, is mainly done by retroviruses. So during evolution, during million years of evolution, we have been infected by retroviruses, and sometimes the viruses was stronger, and then the population died because the virus gets pandemics. But then we fight against these retroviruses, and during years, the virus was integrated in the germlines. So now the next question, is it beneficial? Of course, we have some case where the infection by retroviruses during ages has been beneficial. I take just one example. You know that placenta, it's very important during pregnancy, and placenta is important for the development of the fetus. And this placenta is present in mammals because during the evolution, during ages, we have been infected by retroviruses. And this retroviruses is an endogenous retroviruses named HERV-W. And W because the retrotranscription is initiated by a tRNA tryptophan. So during evolution, so we have been infected by this virus, which is syncytium, this envelope encode for the syncytin, in fact, and syncytin then give rise to the syncytiotrophoblast, which then gave rise to the placenta. So with this example, infection of germlines was beneficial because the mammals was able to develop by creating the placenta. So this is one example. So is it possible to be again infected by retroviruses? I would say yes, of course it's possible. But so far we have no case again.
And I may add more anecdotically the case of herpes virus 6, HPV6, that was found 10 or 20 years ago, integrated in germline of a Japanese family. So it exists. There is human beings in the world with a recent germline integration of virus. This one was not a retrovirus, it was an herpes viridae. And, but it is really anecdotal, it is infrequent, and it was, according to my souvenir, not associated with any specific form of disease, nor any cancer, any tumor.
Okay, thanks. We have one question in direct who asks, in stem cells, is it possible to find HPV integrations? There is any evidence of HPV integration in stem cells? You have an idea?
In which cells?
Stem cells.
Stem cells.
For me, I would say no, because hepatitis B has a tropism.
C'est HPV or HBV?
HBV, hepatitis B viruses.
I would say no, because you can complete the answer.
Yes.
Because hepatitis B virus has only just one tropism, is hepatocytes. That's it. And I think that there is publication saying that hepatitis B can infect B lymphocytes or whatever. But I think that there is no real data on that, convincing data. But for me, it's just one tropism is hepatocytes.
Yes, but then we enter in the quarrels, in the debate of the biologists, and in an adult liver, there is stem cells that are responsible for the production of new fresh hepatocytes and of new cholangiocytes, the cells responsible for conveying the bile in the intestine. And there is the small population of stem cell niche within the liver, and it has been claimed by a researcher that these cells were the privileged target for transformation and are responsible for the development of tumors. And in fact, it is true that in liver cancer, there is some tumor that resemble a lot to stem cells tumor, while others are more differentiated and still remind what was the original hepatocyte, fully differentiated. But in fact, we don't know if the virus infect one of these few members of the stem cell niche, or whether after infection and integration, for example, of HPV, there is a kind of de-differentiation. The cell will get rid of some differentiating marker and will retain only what correspond to the division, to the mitotic apparatus, and so will look like a stem cells. So it's a bit the problem of the egg of Christophe Colomb. We don't know exactly
the question. Yes, but stem cells is very. The question is a little bit strange. Not strange, because stem cells could be from everywhere, and then it could be differentiated in everything. But what Pascal is saying is stem cells from liver.
Adult stem cells
in
liver.
In the liver.
Okay. Stem cells.
So yes, but you have stem cells. When you differentiate stem cells, you can have.
It's not embryonic stem cells. I mean, it is not like germline or primary germ cells infection with HPV.
So we need to be careful.
Yeah, it is adult stem cells.
Yes,
stem cell. Okay. Differentiated organs.
Okay, thanks for your answer. We have one question. We say in this MOOC, you say that 12 to 15% of cancer are linked to viruses. However, many recent publications suggest that many viruses, not yet considered as oncogenic viruses, in particular the EBV and CMV, are suspected of being linked to the development of tumors. Do you think this number will increase with time, and if so, up to what percentage?
So I will begin, and you will maybe complete what I will say. The viruses are suspected to be responsible of all the tumor you can imagine. I mean, there was suspicion for breast cancer, there was suspicion for brain tumors, there was suspicion for any kind of tumor that a virus, a well-known virus or a new virus, could be involved in the development of the tumor. A few years ago, there was this famous, you remember, this murine retrovirus that could have been responsible for prostate tumor or that kind of thing. I mean, there is between 𝐏𝐚𝐬𝐿, there is always a big gap between the suspicion and the bona fide admission by the community, the scientific community, that the virus is responsible of the tumor. And now with the high throughput molecular technique, you are capable to detect many agents in the tumor. When you look in a tumor, in a liver cancer, for example, you will find sometimes Epstein-Barr virus integrated. You will find sometimes roseolovirus HSV6 integrated. You will find sometimes adeno-associated virus 2 integrated in the virus, but in the tumor, in the genome of the tumor. But it does not mean that these viruses are responsible for the development of the tumor. You may even find some pieces of bacterial DNA integrated in a tumor. But it does not mean that this piece of bacterial DNA will be responsible of the development of the tumor. So to be sure that there is an etiological link between the infection and the tumor, there is several criteria that has to be checked. Otherwise, it will remain a kind of general suspicion, and it is legitimate, but it necessitates really proof, epidemiological proof, biological proof, animal model, plausibility, kind of, the sequence of the event between the infection and the development of the tumor should be perfect and consistent with the infection and the disease. And all these parameters, it is called the criteria of Bradford-Hill, are not always present, and therefore the scientific community is still reluctant to accuse a virus to be responsible of cancer. It was the case for the polyoma viridae. You know, the SV40 is a really potent agent to trigger tumor in rodents. And it has been looked for in human tumors many times, mesothelioma, tumor of the brain, etc., for years. But finally, it was a failure. The SV40 and its cousins of the polyoma viridae family are so far not involved in tumor process in human, except the recently described Merkel cell carcinoma virus that is associated with a specific type of skin tumor. That's what I would like to say.
Okay, so we have one question related to the first one. Don't we now have the means to get things done more quickly and get out of the grid zone as quickly as possible? So if you need money, I think it's now, Pascal.
No, I mean, there is no way to be sure quickly that a virus is responsible of a tumor. I mean, you have to engage in many epidemiological studies to gather the samples. I mean, you have to have control. It is really complicated. It is not, again, the new technique of sequencing are so powerful that you are capable now to pick up a small sequence belonging to different virus or not virus. It can be fungi, it can be bacteria, it can be protozoa. You can find anything in a human being. In fact, we have a flora. We are a kind of community, of symbiotic community of ourselves with bacteria, commensal viruses, bacteriophage, etc., etc. So you will be capable to pick up this agent, but it will be difficult to relate this agent with a specific tumorigenic process. That's my opinion. Maybe there will be, I might change in the future if someone prove I am wrong. But so far, we are not progressing so fast in the association of infectious agent and tumor process.
Okay, thanks. One question concerning SARS-CoV-2. Is there any first data to suggest that SARS-CoV-2 can induce tumors?
The question is open, of course, but I will take just one example to answer to these questions. You take just two viruses. You got a course on HTLV1, and there is his cousin, which is HIV1, okay? It's two retroviruses which both infect T cells. So HTLV1, as you know now, it's associated with adult T leukemia. So it's a very aggressive cancer. And they're belonging to the same family. They are both retroviruses. But HIV1, in his own, be careful what I'm saying, in his own, by the virus itself, it's not linked to cancer. Of course, the treatment during a long term will be linked with cancer, but not the virus in his own. Why? Because HIV1, when it replicates, it's killing the cells, it's lytic. The virus is going outside. Okay, so the cells has no time to get transformed due to shutdown of the p53, upregulation of oncogenes, mutations. So because the virus is wake up and then the cell is lysed. At the opposite, HTLV1 is virus which is integrated and it's growing with the cells due to clonal expansion. So the cells have much more time to get transformed. For SARS-CoV-2, okay, SARS-CoV-2, it's, of course, the pandemic is recent, but coronaviruses exist during ages. And so far, we have not seen any type of cancer associated with seasonal coronaviruses, nor with the SARS-CoV, the first coronaviruses described with the pandemics, or the coronaviruses associated with camel in the animal. So I would say no, but I don't know. Maybe Pascal.
But there is paper. Yes, maybe the students have seen paper. Yes, I myself review those kind of paper.
Yeah. What is described is, for example, there is some proteins associated with SARS-CoV-2 that block the activity of P53, block the retinoblastome activity. But this is one point. But then make correlation between this argue and the presence of cancer is two different things.
Yes, exactly. It is a bit the story of SV40. I mean, all of us, we have manipulated SV40 plasmid, and we never get, there is no tumor associated with SV40 infection. SARS-CoV-2, there is paper describing the retrotranscription of the SARS-CoV-2 genome and its integration in cells, but all have been recreated in vitro, in cell culture. So, I mean, it's a kind of, for me, at the moment, I will be blunt, it's a kind of fairy tales to make cry the children. I think there is no real tumor process associated with SARS-CoV-2 infection. But there is, I mean, deterioration of health status of cancer patient, already cancerous patient infected with SARS-CoV-2. There is a huge literature about the deleterious effect of SARS-CoV-2 infection on patients with already a tumor. That is a serious problem.
Okay, thanks. We have one question. Alors, can the gut microbiota and probiotics have a role to play in improving vaccine or treatment response? So it's not directly linked to the viruses, but I don't know if you have an answer.
Please.
It's a little bit difficult.
Yes. So a few years ago, there were huge publications, really interesting in Science, in Nature, from groups working in Institut Gustave Roussy, south of Paris, that describe the beneficial role of some version of the microbiota for some chemotherapy against colorectal carcinoma, for example. It was involving cyclophosphamide or other chemical drugs used in chemotherapy. So I think, of course, that the microbiota is important to define the functionality, the architecture of our immune systems. And if we do have a good microbiota, we will be to some extent protected from the tumor, and we will be and we will react better to the chemotherapy. There is a nice paper about that, a nice review. So there is flora that are defavorable to the outcome of a chemotherapy, and there is flora that are associated with an improvement or a quicker recovery from chemotherapy, because chemotherapy is toxic and it is killing, let's say, for example, the bone marrow cells. If you have a good microbiota, you will escape this effect to some extent. It is not magical, but of course, microbiota is, I agree, is really important, and it is a domain that will, I think, evolve a lot in the next decade. It is really, I think, it is a promising field of research for cancer treatment and any kind of human disease, in fact.
Okay, thanks. We have one question for Maria Boussali, who asks, are there any factors or molecules that help or induce HPV integration in chronically infected hepatocytes?
It is a question that was asked a long time ago, In fact, from what I know, it is that when you are infected with a huge viral load, with HPV DNA copy number per ml above, let's say, 1 million or 1 billion, or even more. I have seen patients from Laos who have 10 to the 30th copy per ml of blood. So these people, they are overwhelmed by viral genome, and there is a high risk that at least one of them gets integrated in a wrong place in our genome. So I think that it is a good starting point to see how it can work. It is just a kind of action de masse. I mean, if you have a lot of virus, you have a high risk to have an integration in a tumor. You are at risk. If you have low viral load, you are less at risk to develop hepatocellular carcinoma with an integration. And there is population in the world with really low viral load. They are infected. They develop a liver cancer, but they do not present any HPV DNA integration in their liver cancer. So, okay, another question that I asked myself to some extent a long time ago, it was, is there a chemical compound that are susceptible to increase the rate of HPV DNA integration in the tumor? And I always wonder whether the aflatoxin B1, that is a mycotoxin, that is directly genotoxic, that it is breaking DNA in our cells. I think that there is some reason to believe that it contributes to the presence of HPV DNA integration in the tumors of infected patients. But I mean, it is a bit lateral. It is not. There is no direct evidence, proven evidence of.
No, I think what Pascal said is a good point. If you have some molecules, it's speculation, of course, but if you have some molecules which enhance double-strand breaks in the DNA, in the genomic DNA, probably you will enhance the probability of getting the virus integrated. So, but it's speculation, but maybe it could enhance the integration.
Yes, but I mean, we are doing that sometime with when you want to, a long time ago, when we don't have a retroviral vector, we would like to integrate a plasmid DNA in a cell line and creating a kind of stress and little DNA breakage was favorable to the selection of an integrated plasmid in a stably integrated plasmid. So I think, of course, there is a link between genome maintenance and breakage of the chromosome and the integration of HPV. But in vivo, it is not easy to measure. That we can say it is that in the countries where there is a lot of aflatoxin in the food, there is generally HPV DNA integration in the tumors.
So during the progression of the cancer, you have some molecule that protects the mutation in the DNA that be then mutated, or protein that protect double-strand breaks, and then during the advances of the cancer, those molecules are mutated, and maybe at the end you get integration of the virus.
Or I suspect that even worse, our DNA repair apparatus sometimes makes a mistake, take the DNA of the virus and take a piece of our DNA and put them together, because it is their job to put the pieces of DNA all together to make a continuity. And the genome of HPV is so special, with a nick in the DNA, with a triple strand at some point, with a single-stranded region, that it is on the molecular point of view, HPV genome, when it enters in the nucleus of the cells, it is an abnormal molecule. It is an unseen molecule so far for our cells. So I think that this weirdness of HPV genome participates to the integration.
just as virologist and the director of the course of virology was saying that the virus doesn't encode for a protein that lead to the integration of the virus. At the opposite, or with HIV, where you have an integrase and the HIV is integrated. So this is an accident during time and during progress of the disease.
I agree with that.
Okay, thanks. We have two questions. We have one question for Ulas Tongkapan, who asks, we know that immune response against viruses can vary among individuals. Is there any evidence that such variation can contribute to viral oncogenesis or progressions? And we have another question who asks, is the frequency of viral-induced cancer increased in transplanted individuals?
Immune system, of course, I would say that is obvious, because if you are immunosuppressed, you have no immune system, strong immune system, and then you will not fight against tumoral cells. So there is an obvious link with immune system.
Yes, it is the case for hepatocellular carcinoma. In Africa, for example, there is a lot of patients who are infected with hepatitis B virus and by HIV, and those unfortunate patient will generally develop the liver cancer with an earlier onset than people who are only infected with hepatitis B virus. I have participated to a study in Mozambique where these patients co-infected develop liver cancer 13 years earlier than people, equivalent patients who were not co-infected with HIV. So of course it is, we know with all the stories about checkpoint inhibitor and the role of immunity in the development of tumor, that if you impair a good immune response, you will get a faster tumor, faster growing tumor, and an earlier onset. And it is the case for retrovirus that are shattering our immune capacities.
Okay, thanks. We have one question about HTLV1. Someone asked the risk of death following exposures to the HTLV1 viruses for both adult T-cell leukemia and TSP and HAM seems to vary considerably from one region of the world to another. Is this essentially linked to the possibilities of medical management, or are some phenotypes more aggressive than others?
Yeah, thank you, Rodolphe. You have the answer in the question. You have two things. Either the virus is different, or there is a better treatment in some countries. And the answer is there is no difference between the virus. The virus for TSP or T-cell adult leukemia, the virus is exactly the same. You got in the MOOC the course of Antoine Jessin with describing the variability of the HTLV1 virus, and the virus is exactly the same. And I would say that probably the difference is done to different type of countries, where you have poor, unfortunately, and rich countries, but you have access more easily to the therapy in rich countries versus poor countries.
I think so. It is visible for any kind of tumor, especially, for example, cervix carcinoma in Africa, where the death toll is really huge, while in Europe it is still important, but it is more or less controlled by the regular test that benefited the women, the women population in European country. So yes, I think that the difference is there. I'm not a specialist at all of HTLV1.
Okay, thanks. We have one question for you, Pascal. There are actually 8 hepatitis B viruses genotypes. Are some more oncogenic than others?
Alors, there is not 8 genotypes. Who is asking me this question?
I have to find the name. I don't find the name.
There is another. There is another one was added, in fact, 15 years ago. It was genotype I. Genotype I is a funny genotype present in on the fringes of Himalayan mountains from the Tibet to the Vietnam. And it does not infect so many people, but it is the 9th HPV genotype. And of course, there is huge difference between genotype between HPV genotype regarding their pathological behavior. And it is generally considered that the genotype C of HPV is the worst because it is capable to generate huge viral load, so high risk to have an integration. And it is generally the period of immunotolerance where these viral loads are really high is long, while there is tumors, there is genotype where the patient, the infected patient, for a reason or another, is capable to see and to mount an immune response earlier against its genotype. And it is generally the case for genotype A and genotype D that infect the European and the African. In Asia, the genotype C is worse than genotype B, but you have to know that the physiopathology of the disease is different as well, because in Asia, the virus, in Eastern Asia, in Asia-Pacific region, the virus are generally transmitted at birth or in the perinatal period, really early, when the little baby is, is immunotolerant to anything. So it will, the virus will find a good place to replicate, and then it is generally the pattern in Asia-Pacific region. While in Europe and even in Africa, even in sub-Saharan Africa, viral loads are lower, and then you are not flooded by billions of viral particles every day, and so you are less at risk to develop a tumor. But what I should say, it is that in sub-Saharan Africa, for example, there is a lot of aflatoxin that synergizes with HPV infection, and there is also poor nutritional condition that impairs the development of a good immune response. So we are here talking about all the topics we alluded to just before. There is the virus, there is cofactor, and there is immunity. And all these players are really important, either to protect you or to make you more susceptible to the development of the tumor.
Okay, thanks for your answer. We have one question. What is the recent ongoing research on integrating and leveraging biobanking data for personalized medicine in viral cancer? Not easy.
For me, it's easy because I'm working.
It's easy. Perfect.
I'm working in Peru with a medical doctor named Sandro Casavilca, who is working in the Peruvian National Institute of Tumor. He is doing biobanking, but he's doing biobanking to do research. It is not yet at the point where you can do personalized medicine. It exists in South America. It exists in Porto Alegre, in Brazil, for example, where they are doing such kind of thing. But according to me, there is no, for the virus-associated tumors, there is no specific drugs capable to target the virus and to cure the tumor. So I don't think that the links between biobanking and personalized tumor are so far functional in most countries of the world.
Okay, thanks. Well, one question for you, Jean-Pierre. are ApoBex3 members all capable of inducing mutation in tumors?
In fact, thank you, Rodolphe, for this question. In fact, just to make a long story short, in fact, in this family, we have 7 genes. And you have some genes, some proteins, some enzymes which are localized in the nucleus, some enzymes which are also localized in the cytoplasm and nucleus. So we can say that probably the enzymes which are localized in the nucleus could be linked with cancer. The answer is yes for some. I say yes for some because we get some proof that those enzymes are linked with editing of the genomic DNA. So we have 2 candidates which are linked with the mutations. I'm not saying cancer, I'm saying mutations. It's ApoBex3A and ApoBex3B. So far, we know that those 2 enzymes can make mutation in the genomes. Now, there is different group, in particular in Cambridge, the group of Stratton, where they have sequenced 7,000 type of different cancer, and they have demonstrated that there is specific signature due to ApoBex3 in cancer. So we have the genomics of the cancer, we have the mutations, and then probably those enzymes did the mutations. But we have no real model saying that if this ApoBex3A or 3B are upregulated, is it correlated? Is it giving rise to a cancer? We have no real proof for that.
Okay, thanks. We have another question concerning ApoBex3. Can all oncogenic viruses induce an ApoBex3 mutational signature, or is it necessarily linked to the production of interferon type 1?
In fact, we don't really know how the ApoBex3 localized in the nucleus could be upregulated. Okay, we have evidence that for ApoBex3A, at least that type 1 interferon alpha and interferon beta, could upregulate the expression of ApoBex3A. But the other ApoBex3, which are localized in the nucleus, we don't really know how they could be upregulated because we haven't nicely analyzed the promoter of this ApoBex3. So far, we can say that interferon type 1 could be involved in the upregulation of 3A. To my knowledge, I'm not really convinced that some viruses could upregulate those ApoBex3 molecules. But I'm saying that because I don't understand why the virus could be upregulated, an ApoBex that will kill then the virus. It is a little bit contradictory. So up to now, we know that it's type 1 interferon that could upregulate mainly ApoBex3 enzyme.
Okay, thank you. We have 2 questions concerning HPV. Why is hepatitis delta a risk factor for hepatocarcinoma tumors during HPV infections?
Why? It is a risk factor of, it is, in fact, it is adding to HPV some risk. In fact, it is an extra risk to develop hepatocellular carcinoma. The evidence for that is essentially epidemiological. They were epidemiological at the beginning. People observed that patients infected with Delta plus HPV are more at risk to develop liver cirrhosis, and liver cirrhosis is a condition that sets the stage for liver cancer development. So that's, for me, it's the main reason. It is a virus that increase liver disease. It is not really an oncogenic virus, but it is a virus that on a microenvironmental point of view, immunological point of view, will stress a bit more the liver tissue and facilitate, promote the promotion of liver cancer. Concerning the molecular mechanism, you know, we biologists, we we love to identify genes and protein responsible for specific oncogenic events. I cannot say that anything has been conclusively demonstrated regarding an oncogenic property of Delta virus. So for me, it's indirect. That's something linked to the liver disease per se, the inflammation, the regeneration, and the sufferings of the tissue, damage of the tissue that cannot be repaired because it is too important, too heavy, simply, and it increased the risk to develop a liver cancer.
And in his own, the hepatitis D, the Delta virus, it's defective. He needs to have also the infection to get the liver could be infected with hepatitis B. Both viruses need to be present. In his own, Delta is nothing.
Yes, it is a parasite. Hepatitis Delta virus is a parasite of HPV. In fact, generally, when Delta is there, it is decreasing the HPV replication. Not always, but in most of the cases, it is the situation observed.
Okay, thanks for this answer. Jean-Pierre, you explained that the differences between HIV1 and HTLV1, and one of the students asked, why in the retroviruses family only HTLV1 can induce oncogenesis? Why it's the only retroviruses who can induce oncogenesis?
In fact, in the family of retroviruses, you have the HTLV, which is the prototype. You have HIV and you have fomiviruses. Okay, and fomi is pumaviruses. Fomiviruses, so far there is no disease. No cancer associated with these viruses and could be transmitted from monkey to human, human to monkeys. There is a good example in the States with a zookeeper. The zookeeper will take care of big monkey like a chimpanzee or gorilla, and then they are very often infected because they bite the zookeeper, and the transmission of the virus is going from the monkey to the human. And that's a good example to explain also the origin of HIV that could be got by a monkey by bite. So fomiviruses, so far there's no link with disease. So the own retroviruses, which is I'm not talking about endogenous retroviruses, of course, because endogenous retroviruses, so far to my knowledge, there is no link with cancer. In fact, most of endogenous retroviruses are defective, except maybe 𝐏𝐻𝐿, which can make some retrotranscription. But to my knowledge, there is no cancer associated with 𝐏𝐻𝐿 in human. And the only viruses which is linked with cancer is HTLV1, and even HTLV2 now it's considered as more or less an endogenous retroviruses. There is not many pathology associated with HTLV2.
Okay, thanks. I think that we can take one last question before to close this live sessions. Is TP53 always targeted during oncogenesis virus infections?
I don't think so. I mean, P53, of course, is the target of papillomaviruses. It is the target of polyomaviruses. It is, and of course, it will be modulated maybe by EBV as well. Some of the protein encoded by HBV genome are degrading or participate in the P53 degradation, but it is not, according to me, it is not always the case. Biologists would like to be, it would be the case, but for HBV, it was more or less a failure. For HCV, it is not the case. And no, I will say that it is not a general case.
Yes, I would try to make a philosophic answer. You know, in fact, oncogenic viruses are very clever. The goal of oncogenic viruses, there is no mini oncogenic viruses, there is 7. oncogenic, you have all the viruses in the MOOC, but the goal of those viruses is to push the cells to be transformed and to get a cancer. This is the goal of those viruses. So in fact, it's like RNA viruses, we try to kill the immune system to counteract the type 1 interferon. And oncogenic viruses, the goal is to block proteins that will target the virus. And P53 is known is involved in proofreading mechanism, is involved in reparation and everything. So
in apoptosis.
In apoptosis. So the goal of those viruses is, okay, it could be an accident, but if you kill P53, then you will have a chance to survive. But it's not only P53. This is the goal of those viruses, in fact.
Yes.
Okay. So thank you all. This live session is now over. I would like to tell you that if you have any further question or need clarification, please don't hesitate to use the discussions forum. You can write me and I try to answer to you. Thank you again to Pascal and Jean-Pierre for joining us today, and good luck to those who will be taking the final exam. Thanks.
Thank you. Thank you for asking questions. Bye.
Thank you.
Bye.